Alrighty, find the average rate of change of f of x, which is this function, from -1 to 8. Well, what we could do is plug in -1 and 8. So if we do f of -1 and do f of 8, and then we could find the slope between those two on that interval. So we have -3 log base 10, again, because it's missing, -1 plus 2 is 1, and then we have a plus 3. And then this one would be -3 log base 10. 8 plus 2 is 10, so this would be a 10 in here, plus 3. When we do that, we now have, that would be 3 times 0 plus 3, and this would be 3 times, oops, sorry, these are negatives, -3 times 1 plus 3. So let's see. What that gives me now is a coordinate -1, and it looks like 3. And the other coordinate would be, looks like 8, comma, 0. Because this one ends up being 0, and this one ends up being 3. Now we got to use the slope formula to find slope. So m is going to be equal to the change in y's. So that would be 0 minus 3 over the change in x's, which would be 8 minus -1. That would be -3 over, looks like 9, which would be -1/3, would be the average rate of change on that interval. Next, carefully describe f of x as x approaches infinity. So as x approaches infinity, what's going to happen? Well, as we approach infinity, as the graph goes this way, it is a log, and it's an upside down log. So I know the log will look something like this. All right, and I know there's an asymptote right here. Again, how do I know that? Because the -3 means it's upside down, and it's a log. All right, so as I approach infinity, what's happening to this graph? Well, it is slowly decaying. It is slowly decreasing, slower and slower and slower. So what I'm going to say here is f of x is approaching -infinity at a very slow rate. Okay, so it is approaching -infinity at a very slow rate because this graph can get slower and slower and slower and slower. Kind of like a square root graph, it's just slowly decaying, slowly shrinking. All right, next. How do I find f of -2? Well, I simply plug in -2. So f of -2, let's see what we get there, is -3 log base 10. I'm putting a 10 there to help myself out. And this is going to be, what is it, -2 plus 2 plus 3. When I do that, I get -3 log base 10, 0 plus 3. And what you should realize is this right here is undefined. It's saying 10 to the what power is 0, which doesn't make any sense. So this is undefined. So what that means is, what does this equal? It is undefined. There is no value at that point. We cannot calculate it. Next, 3 times f of 8 plus f of 98. Well, f of 8, didn't we find that already? Wasn't f of 8 0? Nice. Since we have that already, isn't this really saying 3 times 0 plus, well, what's f of 98? Well, we have to find that, don't we? Okay, so let's find f of 98. Let's see. F of 98 is going to be equal to -3 log base 10. 98 plus 2 is 100. And then we have this plus 3 out here. Okay, so won't this piece right here equal 2? Because 10 to the what is 100? It's 2. So won't that be -3 times 2 plus 3? So it looks like f of 98 is equal to -6 plus 3, which is -3. So can I now put -3 right there for f of -8? And that would be 0 minus 3, which is -3. would be the value of those two. So next, as x approaches -2, what happens to f of x? Well, if we look back at this sketch, we know we can't approach on the left side because there's nothing there. So as you approach -2, -2 is this asymptote. How do I know that? Remember, it was undefined. And if -2 doesn't make sense, when it equals 0 is your asymptote. So again, what happens is, as I am approaching this asymptote, but as x approaches -2, what happens to f of x? I mean, what happens to the values of f of x? Well, it's going up, 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 up forever. So what I'm basically saying is, as x approaches -2, f of x is approaching positive infinity. It's going to go up, 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 up forever. And so that is what we're looking at. Next, on what interval does f of x have negative values? Well, negative values means below the x-axis. I mean, it's below this axis. So I want to know, first of all, where it equals 0, and then I want to know below that. So first we have to find where it equals 0. So we have to set f of 0 equals f of x. And we're going to solve this right now. All right, so to solve this, we want to know first when it equals 0. So I'm going to minus the 3 over. I now have -3 equals -3 log base 10 x plus 2. I will then divide by -3 both sides. That cancels. I now have log base 10 x plus 2 equals 1. Again, what I did real quick is I switched the sides. I put the log on the left and the number on the right. And this right here equals 1. All right, now I'm going to change this to an exponent, which is 10 to the first equals x plus 2. And then I'm going to minus the 2 over. So it looks like x equals 8. Now, at x equals 8 is where it equals 0. So if x equals 8, I got to see right or left of 8, which is it going to be negative? Well, if we look back at this little sketch again, as we go farther and farther right, isn't it getting more and more negative? So wouldn't it make sense that right of 8 would be negative? So can we test something? Can we plug in a number right of 8, which we did already? Oh, yeah. Didn't we plug this one in, right of 8, and wasn't it a -3? Got it? Isn't that right of 8? Yes. So I do know that. Alrighty. So what that states is that right of 8 is going to be negative values. So my answer for this final answer is going to be values x is greater than 8. Everything greater than 8 will give me values below the x-axis. Now I just did 6 problems without graphing it. You're going to be angry because if we graphed it right at the beginning, all these problems are so much easier. I wanted you to see that you can do them without graphing, but I want you to see now, if we graph it, how easy they can be. And if you take the time on a test to find some graph paper somewhere, graph it, all these questions come so much easier. So here we go. Let's graph this really quick and see how it all makes sense. So first of all, to graph this, the shortcut way, what we first do is we notice our asymptote is at -2. So I will draw my asymptote at -2 right here. Okay, now, once I have that asymptote at -2, I'm going to do the shortcut. My HK is -2, 3. How to get that? The opposite of HK. That's HK. So I'm going to put -2, 3, a dot right there, which is not part of the graph. I go over 1 for 1 dot, and then I go over the base, which is 10, and then down A, which is -3. It would go up 3 if it was a positive A. And there are my 2 dots. And my graph would look something like this. And there is my graph of that log. And I can verify by looking at the coordinate, -1, 3. -1, 3. I also have 8, 0, 8, 0. Oh, okay. All right, so that is my graph. Let's see if it helps, which, let's see, from -1 to 8. From -1 to 8, did I go down 1 over 3? Well, did I go down 3 over 9? Down 3 over 9? Yeah, I did. Down 3 over 9. Or down 1 over 3, down 1 over 3, down 1 over 3. Oh, it works. Describe the function f as x approaches infinity. So as x approaches infinity, aren't we decreasing very, very slowly? -2 isn't undefined. Isn't that the asymptote? F of 8, wasn't that 0? And f of 98 is -3. The graph doesn't really help me with this. So this one's kind of like you can't really use the graph. As x approaches -2, what happens to f of x? Well, as we approach -2, isn't f of x getting bigger and bigger very quickly, very rapidly? Then lastly, on what intervals f of x have negative values? Well, wouldn't it be to the right of this 8? Won't it be going underneath the x-axis from then on out? So that would be correct. So we just did them all real quick from the graph. If we would have done that to begin with, it saved us some time.